So, ladies and gentlemen, I'm saying if we are dealing with double integrals, let's take an example, integrating from 0 to 2 and integrating from 1 to 3 of x y squared with respect to y with respect to x. So that means here x1 is equal to 0 and x2, for this one, x2 is equal to 2, then y1 is equal to 1 and y2 is equal to 3. In other words, we always make sure that we work inside out. We begin with what is inside here and work after evaluating what is inside here, then whatever remains is what we now take in and evaluate it later or finally. So that means if I have this, I can begin with 1 to 3 xy squared with respect to y. So I integrate this function, okay? I integrate this function xy squared with respect to y, keeping x a constant. So this becomes x y cubed out of 3 from 1 to 3. This becomes 8 into, this becomes 3 power 3 out of 3 minus 1 power 3 out of 3. Remember, what is out is x. So this is giving us 27 out of 3 minus a third, everything x. So this becomes 26x out of 3. So what we are remaining with is a function of x, and therefore can go ahead and integrate it from 0 to 2 with respect to x. So that means integrating from 0 to and from 1 to 3 of xy squared with respect to y and with respect to x would give us integrating from 0 to 2 of 26x out of 3 with respect to x. This becomes 26x squared divided by 2 times 3 from 0 to 2. So that would give us, this would give us 13 out of 3 x squared from 0 to 2. And this becomes 13 times 4 divided by 3 minus 0. This becomes 26, and that is 52 divided by 3. So meaning integrating from 0 to 2, 1 to 3 of xy squared with respect to y, then with respect to x is equal to 52 out of 3. But we also have to understand that integral from 0 to 2, 1 to 3 x y squared dy dx, okay, is the same as integrating. Now remember, this integral corresponds to with respect to x, and this one inside corresponds to with respect to y. So if I put the integral limits, or the integral for y limits, I make it like this: 1 to 3 integrating, then 0 to 2. Whatever I put inside will be xy squared with respect to x now, then with respect to y, so that we maintain this one with respect to y and this one with respect to x. If we evaluate this, it will still lead you to this. Let's look at maybe, let me see which other kind of integral, maybe from 0 to 1, from 1 to 2 of x squared y with respect to x with respect to y. So what does this tell us? This is going to give us, I can first evaluate what is inside, so that I have x cubed, okay, integrating from 1 to 2 of x squared, y with respect to x will give us x cubed. I maintain y as a constant, divided by 3. So 1 to 2, this gives us y into 2 to power 3, that gives us 8 out of 3, minus third. So this gives us 7y out of 3. So now what is remaining? I will be remaining with integral from 0 to 1, then 1 to 2 of x squared y with respect to x with respect to y will equal to integrating from 0 to 1 of 7y out of 3 with respect to y. So this becomes 7y squared out of 6 from 0 to 1, and then this finally equal to 7 out of 6.